So what we are looking about, or what we are looking at, is the relationship between technology and automation, and we are focusing in particular on services. So you might ask, why on earth are you looking at services? And the simple reason for that is what you see here. 70% of people actually work in the services, and if you count construction as services, it's even more. And you can also see that in the OECD countries, the share of people working in the services sector has been increasing steadily over time, and this is ongoing. In spite of this, we actually have more or less all the work done on automation and jobs is in manufacturing. And it's about robotics and automation at the shop floor in manufacturing, where you find most of the research. So we thought that there was an important gap to fill, and that's what we are trying to do. So what drives automation in service is an important question. You may actually tell me that services is not important. It's, after all, not that easy to automate the services. We just heard before the lunch break that drivers, which can be considered service sector, it's already being automated by autonomous vehicles. And what we are particularly interested in is these knowledge-intensive services. And you can think about them as processing knowledge, which can be more and more easily codified somehow. And so we see that, for instance, technologies like computer vision, natural language processing, and various reasoning tasks have put a range of services within reach of automation. And this appears to happen fast, and it exposes new services jobs to the risk of being automated and to technical disruption. At the same time as services jobs are becoming more easily automatable, they also become more easily tradable. So that means that, for instance, if we think about a radiologist or an accountant, not only will they face a higher risk for automation, but they may also face competition from radiologists and accountants teleworking from, say, India. So to understand what can be automated and what will be automated, one important question is to ask, what do people actually do at work? And to assess that, there is a very helpful database developed by the US Department of Labor. It's called the ONET database. And it was developed in order to help individuals plan their careers and find jobs that are suitable for their interests and their abilities and their skills. So in this database, you have about 1,000 occupations, and it has a really rich source of information, and it looks at 8 abilities or eight different dimensions, which you see here at the right-hand side of the slide. And these are again broken down into categories and subcategories. And to mention some tasks that are in here, so it's, for instance, working with computers, interacting with other people. You have routine manual tasks, you have routine cognitive tasks in here. So every job has a profile with all these 8 dimensions and all these various features, and at least the relevant ones. So you can have a profile of both the job and the properties of the ideal worker that will occupy this job. So this is a treasure trove for people who want to study automation and jobs. It's a different question whether or exactly how to do it and how to do it well. And on that, people disagree. And there is also some discussion about whether the jobs in the US are representative for jobs everywhere. So for instance, does an engineer in the US do the same thing as an engineer in Sweden? Those kind of issues are debated, but whatever one might think about those things, at least the raw data are extremely useful, and we find them useful for our project. So then what has also often been asked using this kind of information is which task can technically be peeled off and automated. I would argue that that's a completely different question from what have been and will be peeled off and automated. And I'll talk a bit more about that. And that is actually where our project focuses. It's more about explaining the uptake of technology than its impact. We will also look at the impact, but we think this is a really important unanswered question. So that's where we focus our efforts for now. And to do this, we use an analytical framework. And that framework is what we call the task-based model. And it's a model which is mainly developed in the field of economics. And here I present it in a very non-technical way, but it's formalized in terms of mathematical equations, and that's what makes it a bit impractical, and that's where the interdisciplinary work with computer scientists is really useful also to operationalize this type of framework. So if we look at this framework, we have an idea that tasks, the things that you do when you are at work, can be ranked according to how complex they are. So if you look at the arrow at the bottom here, we rank tasks according to how complex they are. So the most complex to the left in the chart. And then we can also look at how automatable are tasks. So this is rising probability of automation, and that is inversely correlated with the complexity. So the most complex tasks are here, and those are assumed can only be done by humans, of course assisted by machines and tools, but essentially there has to be a human in the loop here. So the most complex tasks are done by humans. Then you have an area here that technically is possible to automate, and the technology exists. But for various reasons, the technology has not been adopted. And if we think about the history of technology, we can mention a lot of examples of technology that takes years and even decades to be automated, to be adopted. So that is an important area in this chart, is this that can be or can technically be adopted, but is not. And then we have the tasks that are already done by machine, where it's economically rational to automate, where the organization is ready for automation, and where it's socially and institutionally acceptable to automate. So then a few words about AI technology here. So in one area where we see technology is to expand this arrow and add completely new tasks that have not been done before. And this is kind of an artifact of the way economic models are designed. So you can see we prefer to have the length of this arrow the same. So what is assumed here is that the new tasks are the most complex ones. So they are always added to the left here, and they would replace or shuffle down the entire ranging here so that the least complex falls off. And the length of the arrow would be the same at any point in time, but the average complexity of task will rise over time and as technology evolves. So that is kind of the innovation part of the story. And then we have also this process innovation, which we see here, that you have artificial intelligence will help automate some of the tasks that are done by humans at the time, but with more and better technology, we can actually push tasks into this area. So let's have a closer look at that process. And that can be likened with an onion. So if we think about the jobs that we have been looking at and we are interested in, that's the professional services. And what they do is basically to solve a complex problem for a client. And the first thing they need to do is to identify the problem precisely. And that can not always be easy in this type of profession. So it's complex and it might involve tacit knowledge, professional experience, and even intuition can be important here. So that is why this job has not been automated and is kind of safe from automation so far. But what artificial intelligence can do is to break down the problem into parts. Then it can start codify and standardize the well-defined parts and peel them off and automate them. So that is the technical feasibility part, but then there are other parts here also. So one question here is, how separable are the tasks? So if we use the onion image, if you cut a bit too close to the core, the whole onion will fall apart. And that could be the same with job tasks. So if you cut a bit too close to the core, you might find that the customer value will deteriorate and the job becomes less coherent and useful for the client. So these are also considerations that needs to be made. So if we go back to this, a key area of our project is to study this area where automation technology exists but is not adopted. So let's have a look at how this might happen, that we move tasks from this field and into this. And first of all, what is preventing it from doing so? And here we have a lot of issues that could be looked at. So what prevents or delays technology adoption? So if we consider services automation as an investment in intangible assets, then of course we can bring the standard economic analysis in and look at skills supply and the relative price of capital versus labor. And just an observation in that regard is that interest rates have been very, very low since the financial crisis and even before that. So that could explain, of course, that automation has accelerated for existing technology. And then what is also interesting is to look at the size and the productivity dispersion of firms. So what we are asking ourselves is why some firms adopt technology, why others do not, and what characterize firms that adopt AI technology, and can we predict which firms will adopt AI-driven automation in the near future? And for this, we have the best data there is in the world. We have the Nordic register data, which covers all firms in the economy and all workers, and a lot of detailed information on both the firms and the workers. So what we intend to do is to use techniques from both economics and from machine learning to sort out these questions. I'll get a bit back to that in a minute. But just here you can see the driving forces that we are going to consider, but I won't get into them in any detail now. But I think competition policy and in particular occupational licensing are important issues to look at. So then at this, when we are in this part of, when we are in this part of our ranking of tasks, then the most relevant question to ask is what the impact of automation is, because here we have already looked at what determines automation, whether or not it will be adopted. So just a few words about what has been done here, just to show you how the field differs. So there is one study by two guys called Frey and Osborne, and they were early out, and they found that about half of all existing jobs can be automated in the near future. And what they did was to assume that everything that can be automated will be automated pretty soon. And then you have another study by Arndts and others. They are, by the way, from the OECD, and they found that less than 10% of all jobs will be automated in the near future. And they looked at all these other issues that we just got into, how separate all our jobs, what are the institutional issues, what are the organizational issues, how complementary are tasks, and so on. So, and very few have looked into how many jobs will be created, which is, of course, another important factor here. And then what we will look at in our project, which I will not have time to get into here, but very relevant for the workshop, is whether automation would lead to rising inequality, and whether AI-driven automation in services are gender biased, and if so, against which gender? And that's an interesting question. So then just a few words on how we are going to work. And that's, again, about methodology and why we think we will do better. So what we have at hand here is, as I mentioned, the register data for the Nordic countries, which are extremely detailed and comprehensive, and they also cover a long time period. And then we will use economic theory, the framework that I just showed you, and we will also factor in socio-technical transition theory from our colleagues working on the engineering side. And then we will bring this together into some tools where we will use both machine learning and what we call econometrics, which is a technique from economics where we try to analyze causalities using a large database. So we try to conceptualize this modeling framework that I showed, and that will be done by agent-based modeling. So that will basically be a numerical presentation of the model, and here we can kind of throw overboard all the assumptions and simplifications and and tractability that you usually find in economic models, and allow much more complexibility, and then identify which assumptions that economists make that are crucial for the results, which variables, which factors are the most important for the results here. So that will be first just a numerical version of the model, and we make some prediction here that can feed back into both economic theory and socio-technical transition theory to have another iteration and do it again. And we keep doing this until we are satisfied that this seems to work. And then we actually estimate and calibrate this modeling framework on these data. And we use this to specify the model and then identify which variables we should look into, because we have hundreds, so we have to select some. And then we have data-driven prediction, which we again run through this loop and keep improving our framework. And finally, when we are happy, we bring this to the causal analysis, and then we can look at both kind of exogenous variables like the political or the policy dimension here. So for instance, what is the causal effect of occupational licensing? For instance, that you reserve accounting to licensed accountants. Is that a disincentive to automate because you already have market power? If you open up to international trade and allow Indian accountants to telework, would that have an effect on how likely you are to automate, and what would be the impact on the jobs performed at home? So that is basically what we are doing, and we think it's really exciting. For the time being, we are working with my institution in Norway and Örebro University, and we have also developed a project which involves Aalto University in Finland and Aarhus University in Copenhagen, or in Denmark, I mean, and we are trying to extend this to all the Nordic countries. Thank you.